During this video, we're going to look at summing a geometric series. I'm going to, first of all, talk about the formula that we're going to use and then apply that to two different examples. So let's say we started with a general geometric progression, a plus AR plus AR squared, and so on. So if I'm looking at the sum of that sequence, or that series, it's going to be A plus AR plus AR squared. And my last two terms are going to be AR to the n minus 2 plus AR n minus 1. I'll call that equation 1. And what I'm going to do now is multiply both sides of the equation by R. So that'll give me RSN equals AR plus AR squared plus AR cubed, AR n minus 1 plus AR to the power of n. And I call that equation 2. Now what I'm going to do is equation 2, I'm going to subtract equation 1 from that. So what will happen, equation 2, these will all cancel out, okay, when I'm subtracting. So for example, they will all cancel. And that will leave me with Sn minus Sn equals AR to the power of n minus a. And what I can do this side is clean that up a little bit. So Sn is common, that'll give me R minus 1 equals AR n minus a. And now what I want to do is divide both sides by R minus 1. And that will give me the sum, AR to the power of n minus a all over R minus 1. And that's going to be our formula for the sum of a geometric series. However, you might look at that and say, well, what happens if R equals 1? Then this bottom is going to be 0, and that's going to create a problem. So what we can actually look at is thinking, so if R is less than 1, we can take the opposites of top and bottom. So sum of n is equal to a bracket 1 minus R to the power of n over 1 minus R. So when R is less than 1, we can apply this formula. So in our example here, the first 4 terms is a geometric sequence. In a geometric sequence, R, 4, negative 8, 16, negative 32. What is the sum of the first 10 terms of the sequence? So this is your turn now. What I want you to do, pause the video and attempt to solve this problem. Okay, so writing down our formula that we were dealing with before, identifying what our first term is, so A equals 4, R, the ratio, so negative 8 over 4, our ratio is going to be negative 2. So we want the sum of the first 10 terms, so sum of 10, substituting my information in now. So R is negative 2 to the power of 10 minus 1 all over minus 2 minus 1. And when I calculate that, that's going to work out to be negative 1364. In our final example here, Anne and Kay are employed by a marketing firm. Anne accepts employment with an initial annual salary of $50,000. In each of the following years, her annual salary is increased by $2,500. K accepts employment with an initial salary of $50,000. In each of the following years, her annual salary is increased by 4%. So part A of the problem. What is Anne's annual salary in the 13th year? B, what is K's annual salary in the 13th year? And C, by what amount does the total amount paid to K in her first 20 years exceed that paid to Anne in her first 20 years? So what I'd like you to do is to pause the video and have a go at parts A and B of the problem. Okay, so with part A of the problem, what I'm going to do is to start with by forming a sequence. So initially she's paid $50,000 and then each year $2,500 more. And then the pattern continues on. So therefore, we can see that it's an arithmetic progression as it's increasing by $2,500 per year. So with A being $50,000 and the difference being $2,500. Okay, so using our formula for Tn, it's A plus n minus 1 multiplied by the difference. So term 13, it's going to be 50,000 plus 12 times D, which is 2,500. And that will work out to be $80,000. So in the 13th year, Anne's annual salary will be $80,000. Okay, now for part B. What is K's annual salary in the 13th year? So let's write down the sequence for K. So hers is going to increase each year by 4%. Okay, so A is going to be 50,000 and R is going to be 1.04. So we've got a geometric progression now. So with our formula, okay, and to work out term 13, it's going to be 50,000 multiplied by 1.04 to the power of 12. And that's going to work out to be $80,051.61 to the nearest cent. So you can see K's salary in the 13th year is a little bit more than Anne's salary. Okay, finally now, for part C, by what amount does the total amount paid to K in her first 20 years exceed that paid to Anne in her first 20 years? So what I'm going to do for Anne is work out what she would earn in 20 years. So the sum of 20, so n over 2, so 20 over 2, 2 multiplied by A, so it's 2 multiplied by 50,000, plus n minus 1 times the difference, so it would be 19 times 2,500, and that's going to work out to be $1,475,000. So that's what Anne would make in 20 years. Now let's look at K, and we're looking at the sum of a geometric progression now. So sum of 20, so it's A, 50,000 to the power of n, which is 20 minus 1 all over r minus 1, so it's 1.04 minus 1. And to the nearest cent, that's going to work out to be $1,488,903 $1,488,993. So therefore, the difference is going to be $1,488,903.93 minus $1,475,000, which is going to work out to be $13,903.43. So that means that K, in the first 20 years, will earn $13,903.43 more than Anne.